Okay, so this is the app again, and now looking at a simple electromagnet. Now, where we have current flowing through a wire, remember we've got current and we're going to get a magnetic field, but there's no movement or anything involved here. So this is the right hand rule. It's my right hand, and if I need to predict what's going to happen, here I've got my wire. Put it over the top of my computer like that, and let's say the current is going this way, current's moving this way through the wire. So I take the wire in my right hand, my thumb is pointing the direction the current's going, and my fingers tell me that the field will go round the wire this way. If the current's going that way, point my thumb that way, and my fingers go round the wire this way, the opposite direction. So it's my right hand that helps me predict what's going to happen. Now, in this cell, I've got positive terminal, got negative terminal, and here I've got my electrons in the wire, and this wire is in a single coil. Now, I'm going to turn off my camera because I don't need it right now, and the last thing you want to do is see me. So, here we've got plus, here we've got minus. Now, which direction are the electrons going to go? They're going to be repelled from the minus, they're going to go into the plus. Let's just get rid of my field and my compass, but I can see the electrons. And what's happening? Well, if this is plus and this is minus, the electrons are getting attracted to the positive side and repelled from the negative side. So they're going round this way, but remember that the current is flowing in the opposite direction. Current flows from positive to negative, and the electrons go from negative to positive. So let me get rid of electrons because it doesn't really help a lot, and let's get my compass back. So my compass here, the red arrow is my north, the white arrow is my south. The current is going from plus through this loop to minus. So my right hand, I would take hold of this wire that's in front. The current will be going down. My fingers will be pointing through the loop, going from left to right. So the field is going this direction. So the north arrow is pointing that way, north arrow is pointing that way. If I were to get rid of the compass now and let's see the whole field, you can see lots of mini plotting compasses are here. I can see that the field is doing this now, going from left to right, which is what my right hand was telling me. Current goes down, fingers go through the center loop from left to right. So use your right hand to predict that. Now, what effect is increasing the current going to have? Okay, if I have my compass up here, if I increase the strength of the current, I increase the strength of the field. Decrease, and you see the field fades away, it gets weaker. What happens if I change direction? Well, then the current will be going up this side, up here. So I take my right hand, hold on to that side of the wire, and my fingers will go from right to left, and hence the field here, this is north, this is south, the field is going this direction through the loop. Now, what happens if I add loops? 1, 2, 3, 4 loops. Can you see that the field, here it's dimmer, here it's lighter, here I've got something called a magnetic field meter. Okay, if I use less loops, you see the numbers get less, more loops, numbers get more. You don't need to understand what those readings are, you just need to know that the field gets stronger or weaker. And for the next, so what we need to note down here is to use your right hand rule with the electromagnet to work out the direction of the field. If we have a coil, the more current in the coil, the stronger the field. If we have more turns on the coil, the stronger the field. Use your right hand rule to predict the direction of the field. And if I put a a metal soft iron core in the center here, it would also help to concentrate the field and make the field stronger and more like the shape of a bar magnet's field. Now to go on to the next step, if I were just to switch to alternating current, what is happening? Alternating current, the current is going backwards and forwards, so what happens to the field is the field changes direction, it goes backwards and forwards. And if I stop the simulation, that's what's going to take us on to the next video. Okay, so make sure you've got those points noted down, I said, in your notes, because they're the important things. The effect of the current, more current, less current has what effect, more coils, less coils has what effect, putting soft iron core in the middle, what effect does that have, or a metal core, and alternating current makes an alternating magnetic field. So make sure that's down in your notes, and that's all we have to do here.